Gadi Institute of Engineering and Technology, NH16 Anakapalli, Vishakhapatnam.
Hi students, this is Somesh, Assistant Professor from Dadi Institute of Engineering and Technology. Now I am going to explain the previous paper gate question from EMWTL subject. Okay, gate 2021 question. So this is the question from EMWTL subject. Here, the impedance matching network shown in the figure is to match a lossless line having characteristic impedance 50 ohms with a load impedance ZL. A quarter wave line having a characteristic impedance Z1 is equal to 75 ohms is connected to ZL. Two stubs having characteristic impedance 75 ohms each are connected to the quarter wave line. One is short circuited stub of length 0.25 lambda connected across PQ, and other one is open circuited stub having length 0.5 lambda across RS. So this is the given transmission line. Okay, here 50 ohms characteristic impedance. So this is a short circuited stub having length 0.25 lambda. That means lambda by 4 transmission line. So this length is lambda by 4. So whose characteristic impedance is 75 ohms. Okay, another stub having length 0.5 lambda. This is open circuited stub connected between R and S. That means the length of this stub is lambda by 2. So here a quarter wave line 0.25 lambda, that means quarter wave transmission line is connected between P and R. This is ZL. Okay. So now the question is, what is the impedance matching is achieved when the real part of ZL is? So we have to find the load impedance. Option A 75 ohms, option B 112.5 ohms, option C 33.3 ohms, option D 50 ohms. So this is the given question. Here a lambda by 4 transmission line is connected. This is a short circuited stub having length lambda by 4 whose characteristic impedance is 75 ohms, and this is open circuited stub connected between R and S whose length is lambda by 2. So the actual transmission line characteristic impedance is 50 ohms. So we have to find the ZL load impedance. Okay, so we know that the quarter wave transmission line acted as a inverter. Quarter wave transmission line acted as a inverter, and off wave transmission line acted as a reflector or mirror. That means for lambda by 2 length transmission line, input impedance is equal to output impedance. Okay, in lambda by 4 transmission line, if input impedance is 0, output impedance is infinite. So that means lambda by 4 line acted as an inverter, and lambda by 2 transmission line acted as a mirror. So here same logic is applied. This is short circuited stub. So here input impedance is 0. So obviously output impedance is infinite because the length of the transmission line is lambda by 4 acted as inverter. This is open circuited transmission line, open circuited stub. Here the input impedance is infinite. Obviously the output impedance also infinite. Why? Because lambda by 2 acted as a mirror. So to redraw this transmission line, so there is a line, transmission line, and output impedance. That means load impedance is equal to ZL. ZL. This is P. This is Q. This is R. This is here. Here both are having impedance infinite. That means open circuited. So simply to redraw this transmission line, we'll get this diagram because there is no impact. Both are open circuited. Short circuited line output impedance is infinite. Why? Because length of the transmission line is lambda by 4 here. So this open circuited stub output impedance also infinite. Why? Because this stub length is lambda by 2. So this is the diagram. Now we have to calculate ZL. We know that Z0 is equal to 50 ohms. 50 ohms. Z1 is equal to 75 ohms. This is the characteristic impedance of the lambda by 4 transmission line. This is lambda by 4. This is lambda by 4 transmission. So what is ZPQ? That means impedance, input impedance of the matched line. That means lambda by 4 transmission line. This is what we call Z in, otherwise ZPQ. ZPQ. ZPQ is equal to Z1 square by ZL. So here Z1 is the characteristic impedance of lambda by 4 transmission line. This is Z1, characteristic impedance of lambda by 4 transmission line. So here Z1 square is equal to 75 square. ZL. I don't know ZL. That's why I didn't put ZL. So now question is how to calculate ZPQ. ZPQ. So again, to redraw this circuit, this transmission line, assume this is ZPQ. This is ZPQ. The characteristic impedance of actual transmission line Z0 is equal to 50 ohms. In the given question, matched impedance matching purpose lambda by 4 transmission line is connected. This transmission line is connected. So therefore, for matched transmission line, reflection coefficient is equal to, load reflection coefficient is equal to 0. That is equal to ZPQ minus Z0 by ZPQ plus Z0 plus Z0. So according to this equation, we will get ZPQ. ZPQ is equal to Z0. ZPQ is equal to Z0. That is equal to 50 ohms. Why? Because here impedance matching is achieved. That's why reflection coefficient is equal to 0. So substitute this Z0 value in this equation. We will get the ZL value. Here ZPQ is equal to Z0, that is equal to 50 ohms. Here Z1 square is equal to 75 square, that is equal to 5625 5625 by ZL. So by solving, we get ZL is equal to 112.5 ohms, 112.5 ohms. So here the option B is the correct answer. Thank you.